When I say deep sea exploration, you probably get images of intrepid explorers climbing into deep sea submarines and putting on metal diving suits. It's unmanned and autonomous vehicles that are leading the way in ocean exploration.
Deep sea engineers recently captured footage of an autonomous machine navigating the ocean floor without human control, marking a significant breakthrough in underwater exploration technology. No joystick, just an autonomous underwater genius quietly gliding across the sea floor like it owns the place. And wait, don't even blink, because this thing is moving inches above the seabed, handling insane pressure hundreds of times stronger than at sea level, and it's mapping secrets humanity has never seen. Stick with me till the end, because what they discovered down there, it could change everything we thought we knew about our planet. What did engineers discover in the deep sea? They said that recent expeditions had brought some truly remarkable discoveries, and anyone hearing it could imagine the excitement in their voices as they described engineers capturing never-seen-before footage of machines moving deep beneath the ocean all by themselves. They explained that these devices were not guided in real time by human hands, but instead moved with their own intelligence, navigating the darkest parts of the sea with quiet confidence. It sounded like they believed this moment marked a major turning point in underwater exploration, a point where technology had finally reached a stage most people only used to dream about. They shared that for years the ocean had remained one of the most mysterious places on Earth, with more unknowns than answers, and now these robots were slowly pulling back that curtain. Listeners would wonder, had humans finally created something capable of exploring the unreachable? Would these machines go places that no person had ever seen and bring back stories from the deep? They went on to talk about one of the most exciting examples, the Hydrus underwater robotics system, which had located a 64-meter-long shipwreck scattered across the ocean floor near the Rottnest ship graveyard off the coast of Western Australia. According to them, this discovery made headlines because the robot did not just stumble upon the wreck, it truly identified and mapped it. Later, 2 Hydrus units were sent back to complete the entire survey in under 5 hours, something that would have taken a great amount of time and money if done using traditional methods. They emphasized that underwater operations were never cheap, and said that in a world where every minute underwater cost a lot, saving time meant saving money. They sounded proud as they shared how these machines worked quietly and efficiently, proving that underwater exploration was changing in real time. People hearing the story might have wondered, how did we get from human divers with flashlights to silent robots scanning ancient shipwrecks with such ease? Then, they shifted to another story from China, where scientists created a soft robot named Sea Turtle. They explained that this robot moved only centimeters above coral reefs, like a gentle swimmer gliding through calm waters. It disturbed nearly no sediment, almost 90% less than the heavy machines used before. They noted that this level of care around coral was rare, because coral reefs are delicate and even the smallest disturbance can harm them. They said this sea turtle could move as close as 1 meter to the coral without hurting anything, and could sense tiny changes in its position to keep its balance. It sounded like they believed this robot treated nature with respect, something many machines lacked in the past. People listening might have asked themselves, could underwater robots really become gentle guardians instead of noisy visitors? Could technology actually learn to move in harmony with nature? They also shared that researchers had tested a very small robot that could change shape and survive at a stunning depth of 10,600 meters in the Mariana Trench. They added that the robot crawled, swam, and glided without the need for thick pressure armor, which amazed many people since pressure at that depth could crush submarines. They continued by saying that another group had sent a self-powered soft robot to 10,900 meters, where it flapped its wings for 45 minutes, proving its strength and patience in the deepest waters on Earth. It sounded like they believed these tests were proof that underwater robots were no longer weak prototypes, but real explorers capable of handling the harshest places on Earth. And that might have made listeners wonder, if machines could survive the deepest trench, What limits were left? They commented that all these discoveries showed why this moment mattered so much in robotics. They explained that these machines worked where humans could not go without tons of support equipment. They talked about a tiny Chinese robot fish that was only 32 centimeters long, weighed just 670 grams, and still adapted to extreme underwater environments while scanning life and objects with very little disturbance. They added that normally underwater robots stay far from the seafloor to avoid trouble, but these new machines could move with unbelievable precision. They shared that the sea turtle robot improved noise reduction by more than 76%, reacted quicker, and kept itself stable 7 times better than older machines. And then they pointed out perhaps the most surprising achievement. A company called Impossible Metals created a system that used artificial intelligence to see and avoid living creatures as small as 1 millimeter, with 95% accuracy, while collecting materials from the seabed. They said this changed everything because it meant underwater robots could work without harming life. People hearing this might have paused and asked, could this be the start of environmentally friendly exploration? Could machines finally learn to respect life underwater the way people hope they would? They explained that the footage from these undersea journeys did not come easy. They mentioned that the Hydrus robots used advanced navigation tools and captured 4K video as they swam, then returned to the surface on their own, where engineers downloaded the data. For very deep dives, they said researchers used special carriers or underwater landers to release the robots, and in some cases, remote-operated vehicles filmed them to prove the robots were truly free swimming. They described how some tests took place in deep lakes first and then later in the open ocean. They also talked about docking stations underwater, which let robots recharge without going to the surface. They said this meant the robots could work for long periods, leaving and returning like little underwater workers, finishing long shifts at a job site. People watching couldn't help but wonder, is this really our future? A world where silent machines glide through the ocean like curious explorers, learning as they go, returning home only to recharge before venturing out again. It's thrilling, a little unsettling, and absolutely fascinating. Stay locked in till the end, because here's the real question. How does the machine navigate without human input? They often said that navigational autonomy in underwater machines represented one of the most important steps forward in exploring the deep ocean. In simple terms, it meant that machines could now move and find their way underwater on their own, even in one of the most difficult places on Earth. Instead of always needing someone on a ship to guide them, these machines could think, react, and travel by themselves. Imagine trying to move around in a place where you could not see anything, where the pressure was extremely high, and where communication was very slow. They would ask, how could any machine really work there without someone telling it what to do every second? Yet engineers had built systems that made this possible. They explained that these autonomous underwater vehicles, or AUVs, used different technologies at the same time to move safely and collect information under the sea. People often compared AUVs to something called ROVs, or remotely operated vehicles. They said that ROVs always stayed connected to a ship with a long cable. Someone had to control them the whole time. AUVs, on the other hand, moved freely without any cable. That simple difference changed everything. AUVs could travel longer distances, reach areas humans could not easily reach, and gather information without waiting for instructions. They noted that AUVs did not need someone to sit for hours watching screens and steering them. Instead, they were programmed before being sent into the water and would follow the mission on their own until it was time to return. Would anyone really want to spend months watching screens and controlling every little move when a machine could do it alone? That was exactly why AUVs were so important. They explained that while ROVs sent real-time data through a cable, they could only go so far and always needed people guiding every move. AUVs worked differently. They were given a plan before launch, and then they followed that plan. If they found something unusual, some advanced AUVs could even change their path or finish tasks early based on what they discovered. The idea that a machine could adjust itself underwater without help sounded almost like something from a science fiction story. Yet it was happening. They mentioned Ocean Infinity's Hugin AUVs as an example. Those AUVs covered a massive area of the seabed in only 138 days, while using much less fuel and producing 72% less carbon dioxide than traditional survey ships. They said a normal ship would have needed more than 2 years to do the same job. People would pause and wonder, how could a machine do in months what humans usually needed years to accomplish? Then there was the role of artificial intelligence. They shared that modern AUVs used AI to plan their paths and avoid obstacles. These machines had to think fast because the sea could change in a moment. AI helped them look at the environment, process huge amounts of data very quickly, and make decisions by themselves. It was almost like they learned from their experiences. They used methods like reinforcement learning, where the machine improved by practicing and seeing results. They also used advanced neural networks to understand important information and a system called Hindsight Experience Replay, which let the AUV learn better by reviewing past actions. They asked, was it not amazing that technology now let machines learn from mistakes the same way people did? Obstacle avoidance was another huge part of the story. Underwater, obstacles could be rocks, plants, other machines, or moving objects. The AUVs used smart systems to tell if something was still or moving. They created invisible spaces known as velocity obstacles to predict where possible dangers might be. Based on that, they calculated safe paths. It sounded complicated, but the idea was simple. The AUVs sensed danger and moved in a safer direction. Some advanced models even reduced collision chances by using motion rules based on speed and balance. They often wondered, who would have thought machines could plan their own movements in a place humans could barely see or breathe? They stressed that none of this would work without environmental sensing. AUVs needed to understand where they were and what was around them, especially since they could not rely on GPS underwater. They used devices called IMUs and Doppler velocity logs to understand how they were moving. They also used maps and compared their location to known underwater features to know where they were going. On top of that, they used forward-looking sonar. This sonar sent special sound pulses into the water and listened for the echoes. The system then processed the echoes to identify obstacles. They explained that before making decisions, the sonar data went through steps such as cleaning the image and separating objects from the background, almost like someone cleaning their glasses before looking around. This was done to reduce mistakes and better detect real objects. Would anyone want a machine bumping into something just because the water was unclear? Of course not, so accuracy mattered. They also said that the deeper a machine went, the harder everything became. Pressure grew stronger, temperatures dropped to around 4 degrees Celsius, and complete darkness surrounded everything. AUVs had to survive and operate in all these conditions. Since they could not send high-speed messages underwater, they often used acoustic signals to communicate, but those signals were very slow and limited. That meant they needed to handle most decisions themselves. People always wondered, how on earth did they survive down there, in a place where humans can barely last a few minutes without advanced gear? The truth wasn't luck. It was meticulous engineering and navigation that pushed the limits of possibility. And trust me, you'll want to stay with me till the very end for this part. Why is this discovery important for ocean mapping? He explained that the world was entering a new age where smart underwater technology was changing how people studied the ocean. Many experts were saying it was becoming one of the most important tools in ocean research, helping scientists reach places they could never explore before. After all, the ocean still held many mysteries. He pointed out that even though the ocean covered most of the Earth, nearly 80% of the seafloor was still unknown to humans. He shared that researchers believed this huge lack of knowledge was the reason international groups set a big goal. They wanted to map 80% of the global seabed by the year 2030.
You don't have to have much to start, but through creating partnerships, you can start contributing to ocean mapping.
He spoke about a project called Seabed 2030, which was created through a partnership between GEBCO and the Nippon Foundation. Their mission was to make sure the world had a complete picture of the ocean floor within this decade. He stressed that GEBCO had earlier said only about 19% of the ocean floor had been measured directly at that time, showing how much work remained. It made one wonder, how could humans know so much about space and still know so little about what lay beneath the waves on their own planet? He continued by talking about why autonomous underwater vehicles were so important for this mission. He said these underwater machines could go to places humans could not easily reach, especially deep water areas where it would be too expensive or dangerous to send people. He mentioned that these machines were more efficient and cost less to operate compared to older ship-based methods. He explained that traditional research ships needed large crews and a lot of support, but AUVS could do the job with smaller teams and smaller vessels. He said one of the impressive things about these devices was that they did not use large engines like ships, so they made less noise in the ocean and did not disturb sea life. He added that because they did not rely on constant fuel supply, they could also avoid risks like accidentally harming marine animals. He shared that AUVS usually processed and returned visual data within just a couple of days, making the work faster and more organized. He asked a simple question: if technology could do the same job faster, safer, and cheaper, why would anyone not choose it? He used the example of a company called Ocean Infinity to show how powerful this technology had become. He reported that Ocean Infinity had mapped 125,000 square kilometers of seafloor in only 138 days. Meanwhile, traditional survey vessels would have needed more than 2 years for the same task. He mentioned that this newer method also produced far less pollution, reducing carbon emissions by nearly 3/4. He explained that this made underwater mapping not only faster and cheaper, but also better for the environment. In a world where climate change was a big concern, such improvements carried a lot of meaning. He asked people to think about it. Did it not make sense for science to advance in ways that protected the planet rather than harmed it? He continued by talking about real scientific missions that used this technology. He explained that the Monterey Bay Aquarium Research Institute, often known as MBARI, had been developing advanced underwater vehicles for over 20 years. He said their AUVS, called Dorado vehicles, had been collecting detailed seafloor information since 2004. These machines could scan the ocean floor at a level of detail that gave researchers clearer pictures than ever before. He noted that they gathered data about underwater shapes, rock layers beneath the ocean floor, and many other important features. He explained that as technology improved, these machines were being used for deeper and more specific scientific goals. Then he described a recent expedition near Norfolk Island that showed how impressive this technology could be in real life. He said the Australian Centre for Robotics sent out AUVS that carried special high-resolution cameras and navigation tools. According to him, these machines took tens of thousands of photos of the ocean floor. It was reported that Professor Stephen Williams had said it was the first time anyone had seen certain parts of the Norfolk Ridge in such detail. Each underwater journey covered between 1 and 3 kilometers and captured clear images of areas at depths ranging from 5 to 45 meters that researchers had never seen before. He mentioned that these areas were important because the island sat in a special location between tropical New Caledonia and cooler New Zealand, making it a pathway for many ocean species. He explained that this made the island a natural laboratory where scientists could watch how fish and other sea animals moved and changed as the climate changed. And really, if the ocean was changing faster than ever, did it not matter that scientists had the tools to understand those changes before it was too late? He concluded by saying that when people thought about the future of ocean science, it was becoming clear that autonomous underwater technology would play a major role. He said the push to map the seafloor was not just about curiosity, but also about protecting marine life, understanding climate effects, and preparing for the future. He suggested that this work would help people make smarter decisions about the ocean, whether related to conservation, research, or even global safety. He pointed out that humans had always been explorers, and the deep ocean was one of the last great frontiers. So he asked, if the tools finally existed to uncover its secrets, was it not time to use them fully? With this, we have come to the end of this video. Thanks for watching. If you enjoyed this video, do well to like, comment, and subscribe for more content. To enjoy more thrilling stories, click now on the following video that pops up on your screen.